Hello everyone, and welcome back to Biopedia. Just a quick housekeeping notice before the start of the show proper. The lamellipodium episode is unfortunately taking slightly longer than expected to work through, meaning that it's going to have to wait a few weeks. However, I am still working on it and I hope to release it soon. Now, on with the show. The killer whale, Orcinus orca, is a pretty much universal organism throughout the world's waters today. However, the species doesn't always seem to have thrived as much as today. In fact, phylogeographical and population genetics approaches suggest that, historically, the orca population has in fact gone through a bottleneck. This is a dramatic reduction in population size and diversity, which, even after the population rebounds, can impact the diversity of the future population. As such, evidence for it can be seen in genetic studies population-wide. Mitochondrial and nuclear DNA evidence has shown that the global killer whale population was mostly stable throughout the Pleistocene, a geological epoch which began little over 2 million years ago. We will likely as not come back to its successor epochs, the Holocene and the Anthropocene, in future episodes, as they are standalone topics on their own, but for now just bear the Pleistocene in mind. During the interglacial period before the last ice age in this epoch, killer whales had a high effective population size. However, they have been shown to have gone through one period of decline during the last glacial period, known as the Weichselian period. Now, a bit of context is needed on dating here. The Earth has been oscillating between glacial and interglacial periods for the last few million years, with the most recent ice age from 115,000 to 11,700 years ago. This is known as the Weichselian glaciation. The warm interglacial period before this is known as the Eemian period, which lasted from approximately 130,000 to 115,000 years ago. The ice age before our own, and thus before the Eemian, is known as the Salian glaciation. We won't need to go any further back for this episode, although it should be noted that there have been 5 interglacial periods during the Pleistocene. For now, bear in mind that the sequence goes like this when travelling towards our own time. Salian, glacial period, the Eemian, interglacial period, and the Weichselian, glacial period, and the most recent ice age. But back to orcas. DNA evidence shows a decline during the last glacial period, with one interesting exception in South Africa, where diversity remained an order of magnitude higher than elsewhere in the world, and where the local population remained relatively stable. To explain why this decline may have happened, we need to examine this anomaly in South Africa. About 10 million years ago or so, a cold water current arose in the region, which is called the Benguela Current. This current supports high ocean productivity today, and this intensified during the so-called Pliocene-Pleistocene geological transition over 2 million years ago. There are 3 more such currents worldwide, one off the coast of Chile and Peru in the southern hemisphere, and 2 in the northern hemisphere. However, only this Benguela system appears to have been consistently productive throughout the hardships following the Eemian interglacial period and into the Ice Age. Scientists believe that denitrification during the Eemian interglacial period may have led to a decline in marine productivity worldwide. Given that the diversity of orcas remained 3 to 4 times higher in this Benguela current area than elsewhere in the world, it suggests that something akin to a refuge formed there. This implies that marine productivity might be tied to the welfare of global orca populations, given that the Benguela current was the only one that remained stable during this time, and the only place where such an anomaly occurred during the decline. Other factors such as prey redistribution or even human activity cannot be ruled out entirely, as whaling has been shown to have taken place as far back as 6000 BCE, and did include the hunting of killer whales. However, it seemed unlikely to the authors of the study that we would have a sufficiently large impact as a species to be the cause of this decline. The effective population size of killer whales increased again as the last ice age ended and the Holocene began, 11,700 years ago or thereabouts. As the adverse conditions of the last glacial maximum, with its low temperature and unstable climate, receded, mitochondrial evidence shows us that the population rebounded again into the Holocene period. So, Why is this important? Well, killer whales are apex predators sitting at the top of their food chain. These top predators can act as so-called sentinel species, acting as an indicator or a warning about the health of the rest of the ecosystem. In the case of the orcas, stable productivity of the oceans might be vital. Apex predators, after all, depend on a lot of prey, meaning that changes in ocean productivity would have a severe indirect effect. This study shows that drastic changes in climate can be associated with population declines of even the most iconic species, something we should bear in mind as we head into our own anthropogenic warming and the sixth mass extinction. Thank you for listening. If you have any questions, comments, future topic suggestions, or just want to say hello, feel free to get in touch at biopediapodcast@gmail.com. Thanks again for listening, and until next time, have a great week.